Hi, today we're going to talk about the SoleusAir Tower Fan. I had a squeak every time I used the oscillating function, so I'm going to go over what I did to fix that and the general maintenance. This is the SoleusAir Tower Fan, and it was squeaking whenever I was in oscillating mode. So there are two ways to do it. You can buy a new motor, which is about between $5 to $10 US, or you can repair the existing motor, which is what I did. We'll cover some of the general steps. Just to let you know, though, I did repair my own motor. So buying a new motor should be fairly simple, but it may take a little more than what I'm showing in this video. General maintenance should be really every 2 to 3 years. Basically what happens, the grease gets old, gums up, and then loses its lubricating properties and is going to start to burn. Not in the way of causing a fire, but you will see that the grease is going to start getting black. And without that lubrication, the parts are going to wear out, especially not necessarily the plastic to plastic parts, but the metal on metal. Definitely we'll see a few pictures of that. So we're going to re-grease those moving parts and vacuum up the dust at the same time. Before we go any further, at the very bottom, this is the actual motor that's responsible for the oscillating feature. Just wanted to show you that in advance. It's at the very bottom of the tower fan. This is the fan itself from an area after I've removed almost everything. And the way you'll be able to tell that this is the offending piece is if you turn the fan on, and yes, you can turn the fan on while it's disassembled, because both these motors are really light and not very powerful at all. If you lay it on its side or move this motor around as the fan is on, you're going to hear it vibrating or squeaking. And what that is the little tiny plastic gears inside. The teeth are rubbing against the metallic case. So if you sort of play around with this little motor while it's on, you're going to hear it grinding. And the reason is because the grease in it is all dried up, so the parts are loose in there, and so that's allowing those gears to rub things that they shouldn't. If you are intending to purchase a new motor, this is the motor that's inside the SoleusAir Tower Fan, at least the one that I had. And what you're looking for is a TYC50 or a TYC-50 style motor. This one is 4 RPMs, although you could change yours obviously. In the United States, this is going to be AC current 100 to 125 volts. If you're in a different part of the world, that may need to change for you. 50 to 60 hertz, and this one runs clockwise and counterclockwise, which is important because there's really only one way that this should rotate so that the arm works correctly. And if you get the wrong rotation, all you need to do is swap the wires on this one and it'll rotate the other direction, so that's sort of nice. If you're buying a new motor, look for TYC50 on something like Alibaba, eBay, Amazon. They all run from anywhere between $5 to $10, so not that much at all. One thing to note is I had trouble searching for an actual 4 RPM motor, and 1 revolution per minute or 4 revolutions per minute means that it's going to go back and forth, a full back and forth sweep every 4 times every 1 minute, which means that you're getting 1 sweep across the room left to right every 15 seconds. So if you're getting one like this one that says it's about 5 to 6 RPMs, it's going to sweep the room a little bit faster. So what you do is you take that number of RPM and divide it by 60. So if it's the 5 to 6 RPMs, this one's going to sweep the room every 10 to 12 seconds, and a slower RPM, like 2.5 to 3 RPM, is going to move across the room slower every 20 to 24 seconds. So you take that RPM and divide it by 60, and that's generally the number of seconds it's going to take for it to go left and right 1 time. This is the old motor. Now, if you tend to re-grease the old motor, you need to have a plan. Number one, to crack open the motor is pretty simple. All that they did was there's a top. It looks almost like a can of tuna. And then what they've done is taken these little tabs and literally just bent them over the top. So find a way, whether you want to pry it back open with pliers or something like that. I found it a little difficult, so I used a rotary tool and just grinded them off, and the top popped right off. And then you have to have an exit strategy of how you're going to keep that top back on, whether you choose to Gorilla Glue it, solder it back on, or literally just take a hammer and cut two new tabs and bend new tabs over to lock it. And that's what I chose to do, just because I'm anticipating that in another 3 or 4 years I'm going to have to get back in there and re-grease it. Okay, tips before we go. There are 4 or 5 different screw types, so make sure you label and organize them. Most of these screws are just screwing into plastic, so it doesn't need to be super tight. Just keep it finger tight. Do not over tighten it, because if you do, what you're going to end up having is plastic being torn into the threads inside that are just going to tear, and that's going to be bad if you intend to maintain it long term. Tools required: small Phillips head screwdriver, the vacuum, of course. All-purpose white lithium grease I used for the plastic pieces. For the metal contacting areas, I used something a little heavier. I just had brake grease around. It's under $1. You can buy a little tiny packet of it from an automotive store. Just ask them. It's usually right up at the counter. And then if you intend on replacing the motor, obviously you need the motor, some crimps and butt splices. If you're rebuilding the motor, get that heavy-duty grease and some tool like a rotary tool if you choose, or something to crack open that motor, and something to seal it back up. Okay, this is what happens when there's a lack of grease. Metal to metal contact without any grease. There's no way for these metal parts to slide against each other, so what happens? They grind against each other. This is just one example. And secondly, my definition of finger tight: people are stronger than others. So the easiest way for me to universally describe this to you is use finger tight as the very tips of your finger at the end of the screwdriver. This will make it a little bit tougher for you to screw, but it means you're not going to use your whole hand and wrist to just mangle that thing. Keep your fingertips at the end of the screwdriver, and once it gets tough, just another quarter turn and that should be enough. So we're going to start by laying this on its face and removing 8 screws. The 2 on both ends are going to be a little bit longer, and I know you're going to label and organize those. On the front, on the bottom, there are also 2 screws that have integrated washers on them, so you're going to remove those as well. Now you can remove the face, and you're going to notice here in this picture I kept the wiring together. That allows me to turn on the fan and turn on the oscillating feature when I want to test it. So you just need to remove the face. You don't need to disconnect the wiring. Once you've removed the face, you can remove the vent mechanism, and at the bottom are 2 screws. At the top is a plastic piece, and you can remove those 2 screws as well. And you're going to notice here plastic on plastic, so I used a white lithium grease here to clean it off and re-grease it. Here's a great time now that the fan cylinder is exposed to vacuum. Underneath, now that we're going to remove the actual fan cylinder itself, at the top you're going to remove these 2 screws, and you're going to notice that there is this rod here that is spinning around on this bearing. That's metal to metal contact, so I used the brake grease again here. At the bottom, to remove the entire cylinder, is a single Phillips head screw. You don't need to pull it all the way out, just enough to ease it out of the motor, the fan motor, and get it past that little indentation. Remember, when you put the cylinder back on, you want to line up that Phillips head screwdriver with this indentation and tighten it down. This is probably the only one where you want to do it a little bit more than finger tight, because it's metal on metal, so there's no stripping of plastic. Once you've removed the fan cylinder, you're going to remove the fan motor itself, which is the big zinc metal motor at the top. It's got 2 screws on both 2 screws, 1 on each side, and you're going to remove the plastic arm mechanism. Again, 1 screw on each side as well. The motor, to remove it from the motor bracket, there are 4 screws on each side. You just want to remove the 2 in the middle on each side. And now that the motor is removed, the bracket is exposed, you want to remove these 3 screws, and that is going to expose the white arm assembly of the oscillator. Now, I'm not going to go into a whole lot of detail about the plastic arm. You can use these pictures as a guide, but I'm going to use white lithium grease around the arm itself. And what you're going to notice is there's the main big arm that oscillates the vent. That's connected to this metal arm right here. And that's screwed into, and it's hard to see, but this arrow is pointing to it. Between the actual motor and this metallic arm is a small white plastic arm. And you're going to notice here on one side, the metal arm is screwed into the white arm. And then this white arm is connected into the actual rotating rod of the motor itself. And the way that that's connected is with a little pin that slides right through. And I'm going to show you exactly where that pin goes. Now remember this picture. If we go back, you're going to notice that this rod right here is underneath the metallic arm. These were looking on eBay. These rotating rods were a little longer than I was anticipating, so I have a feeling if you purchase it, be prepared to hacksaw it or file it off and shorten it a little bit. But what you're also going to notice is these holes drilled along the sides of the rod here. That is where the plastic arm is connected to the metal rod, and there's just a pin inside it. So you need to push that pin out. All I did was of the loose screws there, I found one that sort of fit through the hole. I just stuffed that screw in and pushed it out, and that was enough to get that pin out and remove the plastic arm from the motor itself. Well, here's some of that grease, metal contact, and you're going to notice here that after time, it's lost its lubricating properties, and so it started heating up and cooking the grease. Because the grease is no longer lubricating, the metal-to-metal contact is basically grinding these pieces away. On this washer, no big deal. I just re-greased it and I flipped it and used the other side. And so what we're going to do is put some grease on both sides of this bearing. Give it a generous amount. Put some lithium grease on the plastic pieces as well. And now we're finally getting to the actual replacement of the motor. There are just two small screws on both sides and you can take it off. That's all there is to be done here. If you are replacing the motor, this is the time to cut the wires. Cut the wires, and obviously the fan should be off. If you're cutting the wires, unplug it from the wall, cut the wires, and then splice in the new motor. Test it out before you reconnect everything, and the reason for that is because you want to make sure that it's rotating in the right direction. If it's not rotating in the right direction as the original, just flip the wires around. And you should be good. Once those butt splices are put back in, you should be done other than testing it out. Now if you want to re-grease the motor, again, there are little tabs that are locking the top on. I just used a rotary tool to grind those off, and the top popped right off. Inside the motor itself are some very small gears. The nice part is they're all totally different. So if you keep this picture as reference, there is going to be no reason that you should get any of these mixed up. Basically what I did was cleaned all of them up, but you're going to notice the metal-to-metal gears are the ones that have developed heat and were cooking the lubrication. And because it was cooking that lubrication, they ended up brushing up against the casing of the motor. Here I used the brake lubricant, and you're going to notice I wiped them all off just with a small paper towel. I added grease on the teeth, in between the teeth, very generously, on the floor of this motor right here, as well as on the little spindles themselves where the cogs are spinning. Then turned it on and worked like a champ. That's pretty much it. Reinstalling it is the reverse. Take your time. Final notes, test the motors, of course, and the arm assembly before reassembling the entire fan. Don't over tighten the screws, especially those in plastic. If the screw doesn't feel perfectly smooth going back into the same hole, check to make sure it's the right screw, or try another screw, or try again. Do not force it to prevent shredding and tearing up those plastic threads inside. I hope that helps you, and keep cool.